Okay, so this is going to be the second part of the last problem I was doing. So we're going, and we were right here. We looked at video 2I, and that's a ball that starts at a balcony, goes up, and comes back down and lands on the ground. And what we just found was we found some conservation of energy. We found that at the bottom it had 0 potential energy and 3.24 joules of kinetic energy. In the middle it had 1.03 joules of kinetic energy and 2.21 joules of potential energy, which meant that it had a total of 3.24 joules of energy total. Okay, so now at the top of its flight, well, right at the very top of its flight, since the ball went straight up, more or less straight up and then straight down, basically at the top of its flight, its velocity right there was 0. So at the top of its flight, I'm going to say its kinetic energy was 0 joules, which means that at the top, its potential energy is going to be 3.24 joules. So now that allows me to say that the height is going to be 3.24 joules divided by the mass, which is 0.055 kilograms, and gravity, which is 9.81 meters per second squared. And so that's going to be 3.24 times divided by 0.055, close that parentheses, sorry, divided by 9.81, and I get 6 meters. Okay, so what that's telling me is that this distance here is 6 meters. Well, let's figure this out. If something drops -6 meters, and its initial velocity was 0 meters per second, and its acceleration was -9.81 meters per second squared, and I want to solve that for time. Well, let's go back to our good old equation. That's 0. So I've got -6 meters is equal to 1/2 of -9.81 meters per second squared, t squared. So I'm going to come up with t is going to be the square root of 2 times -6 divided by -9.81. Throw the units in there. So if I do that on my calculator, I'm going to ignore the negatives. 2 times 6 divided by 9.81, I get 1.1 seconds. Now, and that gets like 1.106. Now I was shooting at 30 frames per second. So I multiply that by 30 and I get 33 frames. Now if I go back and I watch the video, it's hard to tell exactly where the top is, but I would say that it is either 33 or 34 frames for the ball from the time that the ball is here to the time that the ball is down here is on my video somewhere either 33 or 34 frames. So it all checks out. Once again, it all checks out. Okay, the last thing I want to add in here as long as I'm talking is that we can set, okay, how do I want to leave, this is a hard thing to say, but kinetic energy is always positive. Kinetic energy always has to be positive, and if you think about the formula, mass always positive, and anything squared is always positive. Okay, so kinetic energy has to be always positive, or zero. Kinetic energy has to be always positive or zero because mass always has to be positive. And the mass has to be positive. Anytime you square something, you get a positive number. So the kinetic energy has to be positive. But GPE can be negative. GPE can be negative depending on where you set h equal to 0 meters. Because it's really arbitrary. Okay, you go, okay, fine. You say this is 0 meters, and you say this is 4.1 meters, and you say that this is 6 meters, and you go, ha, see, GPE can't be negative. Well, suppose I decide to set this at 0 meters, this at 1.9 meters, and this at negative 4.1 meters. If I went through and I followed through all of those changes, I would still come up with the fact that I would come up with a different total energy, but the total energy would still be the same at all three of these points. Now, so if you think about it, right now, in that video, what you would consider to be 0 meters in that video, well, that porch is really about 20 meters uphill from where I'm sitting right now. So from the standpoint of that porch, I am now sitting at negative 20 meters. And you say, well, okay, that's fine. Why don't you just set your lab to be 0 meters, and then that porch, the base of that porch can be at positive 20, and then everything just starts to get more complicated because you can go downhill from my lab. So you can keep going downhill from my lab. You can go down to the ocean and say, well, the ocean is 0 meters. But then, okay, well, how about something that's underneath the surface of the ocean? Or how about Death Valley, which is below sea level? Or how about the Netherlands, which are below sea level? Okay, well, let's make them 0. Well, what about something, at the bottom of the ocean? Suppose you're in a submarine at the bottom of the ocean. Okay, well, let's make that 0. Well, suppose you're in a really deep well that goes down 3 kilometers into the bottom of the earth. Well, let's make that 0. The point is that it starts getting complicated when you try to set absolute 0. What you really want to do is not worry about whether gravitational potential energy is negative or not, because the only thing that matters